Good morning, everyone. Today, my name is Vahe Gharagyozyan, and I'm presenting PillGuardian small pill dispensing device. And I will start with the agenda for today. First is problem and motivation. Then I will go to market research, requirements and objectives, system architecture, mechanical and electronic designs, mobile app and Firebase, and challenge conclusion and future work. Starting with identifying the problem, the main problem is the medication non-adherence. Patients, especially elderly people and those with chronic disease, forget doses, take the wrong pill, or accidentally take the double dose. There aren't just inconveniences, they can lead to hospitalization and, in a worst case scenario, to death. But there is the second problem, which is overseen, overlooked every time, which is the caregiver burnout. When the family member must constantly monitor the patient's medication, day after day, it creates a significant psychological stress. So this device is addressing both of the problems. Main purpose of the device is to do four things: maximize the medication adherence through automatic dispensing and schedule, enable remote caregiver oversight through cloud-based app, reduce caregiver fatigue by enabling automatic overseeing and no need to be in contact with person, and preserve patient independence because the goal is to support, not to control the patient. I did market research and looked for three categories of the existing solutions. Manual dispensers. They are affordable but offer no safety. They rely entirely on patients' memory and discipline. Semi-manual dispenser add alarms, but they are not giving any control or oversight by the caregiver. And the most advanced option I found is Hero Dispenser. It has the app, it automates the scheduling and the dispensing, but the problem is the price, because it's come not only the price of the product, you're also paying the subscription, which is very high price. It's starting from $50 a month, and if you're buying the yearly, it's becoming $320 a year to just dispense the pills. So with the analysis I did, I defined my core requirements. This includes schedule information, schedule dispensing the correct time, medication safety through control access, patient confirmation before any pill is released, multi-compartment storage for different medication, a mobile app to manage and monitor, Bluetooth connection with the app, with the dispenser, and everything is made from 3D printing except the acrylic out parts, and with using ready off-shelf devices. So the main four components are displayed here. The hardware, which is using to dispense the pills, have the pills inside as a storage, and the LED indication when the time has come. The patient's app, which is installed on patient's phone, is using for local reminders, Bluetooth commands to send to the device, those confirmation and device status. Firebase Cloud used to synchronize everything with the patient app and the caregiver app. And the caregiver app is using to control remotely the device. Also have the missed dose alerts if the patient missed it. Now about the operation overflow. The caregiver creates or edits the medication schedule in app. Firebase stores and synchronizes the update schedule. Patient app receives the schedule and creates the reminder. STM32 activates the correct servo motor. The dose time patient confirms the dose. The patient app sends Bluetooth command to STM. The STM activates the correct servo. Sensor check if the result and check if the tube is empty or not. So to notify the patient or the caregiver. App updates those status and inventory in Firebase, and caregivers can see in history is the dose taken or it missed. Going to mechanical design, the device stands 297 millimeters tall with a base footprint of about 194 by 231 millimeters, which is compact to use everywhere in shelves or on bedside tables. Internally, it's an 8-compartment pill storage chamber, which the central funnel, which is dispensing the pills to drawer, which is in base. Also in base we can see places for STM and power shield, which we'll talk about later. Electronic component choice starting from the main controller is STM32, which gives me enough the GPIO pins to control servos, LEDs, and everything that is connected to the device. For actuation, I'm using Metal Gear servos, so it can for sure dispense the pill and no jamming can happen. The time-of-flight sensors are used just to confirm is the pill empty or not after the dispensing happened. Wireless link, I used Bluetooth model for local control, so the app from the patient is connected to device and talking to it. I use the LED outside of the device to notify when the dispensing time has come, and I use battery shield with 2 battery cells if so the device can work when power is off. Going to hardware connections, here we can see how everything is connected to STM, what are used in case of protocols and everything. Now going to mobile app design, this is the mobile app logo, and with the start is coming the welcoming page and setup profiles for caregiver and the patient. After patient setting up the profile, it will be this home screen, which provides the pairing code, which should be provided to caregiver to connect to this app. The live inventory, 3 pages, home, schedule, inventory, and the inventory have the editing mode. So if the tube is using only 20 pills, but it's capable of taking 30, and the patient needs only 20, it can edit to 20 pills, so it's also the app controls how many pills are left. I will show it in the next slide. This is how editing modes work. We can write the number of pills, and after every time pressing the refill all, it will update this amount that was coded in here. Also, there is color coded version of tubes, so when it's more than 10 pills, the pill tube is green, is less than 10 pills is yellow, and this 3 or less is red. Also, functions that our home screen provides is calling 911, connecting to Bluetooth, and this is how it happens. The patient don't need to add the Bluetooth from the device, you just need to press the connect Bluetooth, connect to PillGuardian, and the program will automatically connect to it. Also, there is a version to change the languages, change the background color, and apply passcode for the dispensing only. Here's how medication adding process is done. From the schedule part, the caregiver or the patient using the plus button on the right can add the medication. The pill can be chosen from the list that is provided with 300 or more pills, or can be written as the patient wants. For example, pill for diabetes, no name restrictions. After that, they need to choose what days they need the pill, how many times a day, and from which tube they are taking the pill. This is how it will look after caregiver app and the patient apps are connected. Patient app can dispense the pill only at the correct time, with a window of 10 minutes after and 10 minutes before. However, the caregiver app, which is on the right, can dispense it anytime. Also, one of the differences between caregiver and patient app is the history, when the caregiver can see what dose is missed or taken. This is the type of notifications the patient and caregiver get when the dose are missed or time to take the pill. And the real life demo of the working prototype. But not everything was smooth as it was shown in the video. It was a lot of connection problem with the Bluetooth, especially started when the name of the component I bought and the actual component was not the same. I bought other component from other name from Armenia, and this was the same. This took me 4 days to debug that problem, and also the connection from my app, because the Billy connection is not accessible from just the phone. It needs the special code parts to access it. The Firebase synchronization took a while too, to identify the roles of the patient and the caregiver and have the pairing code working. The mechanical parts was not very hard, but had the problem too, especially the servo arms which are dispensing. They were jamming under the tubes. They were taking the pill not too far to dispense in the openings. So after some iterations, I had this device ready. For the conclusion, final outcome, the PillGuardian for me, PillGuardian is successfully combines mechanical dispensing, Firebase monitoring, the Flutter mobile app, and the Bluetooth connection. The thing that we don't have in the conclusion is medical grade reliability, and as this is a prototype, it's not include the medical references too much. For future roadmap, I have divided into 3 parts: short term, mid term, and long term. For short term, I want to make the Bluetooth auto reconnection, improve the online synchronization, and apply some polish for two app for elderly use. For the midterm, I want to do the automatic door, which will make the door open after dispensing and close after some time, so patient do not need to remember does he close the door after before dispensing or not, and improve jam detection. So if something happened during the dispensing, the device will understand it and start the dispensing process and or notify the patient or caregiver. For long term, a smaller traveler version, large capacity model, medical grade validation, and integration with virtual assistants like Alexa or Google Home. So it will use the speaker from Alexa to notify that it's time to take the pill. Thank you very much. That's all.
Very good work. Real life problem, real solution. As someone who is an elderly parent who sometimes misses her meditation, I think this has very good potential, and with very little work and tweaking, it's a ready product for market. But you mentioned someone. You didn't mention someone who will be and should be connected. The doctor was prescribed the drugs. So the doctor knows after each visit if the patient has in fact followed his instructions to take the drugs as per the schedule or not, which is very common problem in Armenia. Someone says that I'm feeling well, no need to take the drug anymore. And as some advice for the future, you could add some ultraviolet lamp to disinfect the dispensing door, for example. It will make your product more medically compliant, let's say. And some, for some far future, maybe some companies will issue the drugs in standard tubes, which will be tagged and identified with the type of drug, the drug quantity. Or you can take that as an initiative and work with some companies as an experiment. But overall, very good work. Well done.
Thank you.
Quick question on a little bit on a future vision. Let's say, have you done any marketing study? Like, are there any dispensers in market, and have you talked to the doctors of how demanding this is from their perspective, and how is there like a plan to commercialize this, or
There is a plan to commercialize this as they need it, because not only on home side you can use this, you can use this also in elderly homes, where 8 patients can use 8 tubes. Everyone has with his pills in the tube. About the market research, I did the market research, started from market research from the hero dispenser I showed. The problem with hero dispenser compared to mine is that hero dispenser is not giving the actual freedom for caregiver to dispense it. In the application of hero dispenser, they can just look for the history. They can dispense, they can connect with the patient. And from patient side, I think, for patient side, I think it's a good idea because now everyone is connected to pills, and not only drugs can be dispensed here. It's not designed for the drugs mainly, but all the securities are taken to restrict it.
So my phone always needs to be connected to Bluetooth to be able.
Yes.
Yeah. So and then I need to be in the close region to this device.
Yes.
So I think sometimes the battery of the phone may also.
For that times, the caregiver can dispense it on the time. If it is in other case, if it's not dispensed, the caregiver will get notification that the dose is missed. So it can connect. So if it's not connected, can come to home or dispense from his app.
So there is a Bluetooth module inside this.
Yes.
But can't you put like a SIM card, like a module to have a SIM card and then send the SMS? Wouldn't that be more power efficient for?
We can do that, but I think for the prototype and for the 6 months we have with Bluetooth was the easiest version because I know how to work with it. So I don't need to start.
What is the reason of this huge device?
It's not huge. The reason is to have 8 compartments. The Hero dispenser have 10, but it's using different approach with the dispensing. It's using vacuum tubes to dispense the pill from the pills from in Hero dispenser is just added up. Here is like structured in vertically. To have also everything in lesser size, so it's not very tall, but wide. So it can fit in any shelf. So 30 centimeters is the classical height of the shelf, and this 29 centimeters of height.
So you are not planning to reduce the size?
It can be reduced, but with maybe with a smaller capacity of handling, for example, for 10 days, not for a month. It's designed to handle for a month, so it can be filled up for a month, and no one need to take action.
One obvious question: why you did not do a real-time demonstration?
We can do it, but you will not see anything except that I am taking the pill from the drawer. Because everything is closed here.
You claim it works.
You're sure it's working. Okay, good.